Hello, everyone. This is Jason speaking. Good afternoon to all of you. Welcome to the Supermap JS contest online training camp. And today we will start the content about the 6 days training of development group. Okay, let me share my screen first. And before that, let's take a look at our training schedule. Yeah, every time we will review all of our content. And from the day 1st to the day 5, we already achieved the function of 2D cadastral management development. And here we have 2D left. The 6th day is the 6th day and 7th day. We will focus on the 3D part development. And today, we are going to create the 3D scene and process the 3D data using iDesktop. And we need to use iServer to publish the 3D service. During today's content, you will get the general idea how to what kind of preparation work we need to do before we start the development of 3D WebGL. And tomorrow, that will be the last day of the development training. And on the last day, we are going to start coding about the 3D part. And we are going to show the 3D scene with Supermap using iClient for WebGL. And we want to also achieve one simple question, which is click the building to query attributes in 3D. And of course, that is only an simple start of development of WebGL. And also I will show you some examples, some capabilities to you, and show you how to, based on the examples, to develop your own 3D WebGL application. Okay, so in the day 4, we are going to create the 3D scene and process the 3D data using iDesktop. Now, I already opened the step document of day 6. First, let's take a look at our data. Yeah, this is already the data we have, and we always based on the building to do the cadastral management function, right? And don't forget, we also have one terrain data, which is we imported from the elevation data downloaded from the DivaGIS. And this data can be imported to Supermap iDesktop as the grid dataset. So you can, if you forgot how to download this data and how to import it, you can refer to the first day's content. Actually, that's not hard. We just need to import the RVT data and set the type as grid type, as grid. Okay, now we can see if we want to create the 3D scene, there are 2 things need to be done. The first one is we want to show the terrain, right? We want to show the terrain. And the second one is actually now all of our building data are 2D. So we need to extend them based on the height of them to create the 3D building. And of course, we can give some texture, but if we don't have the real texture, personally, I don't like to put the same texture like the window and the roof picture to all of the buildings. That will be kind of weird, just in my point of view. Okay, so the first one is if we want to extend the building into 3D and also show the terrain of it. The first one is we need to base on this function, which is 3D data, and there is a tintor, and then extract data, extracting 3D data. We can say that is according to the specified parameters, extract the point, line, and surface data from the tin cache. And the result data set is the corresponding 3D point, line, and surface data set. So we can check the panel of it. First, we need the source data. And this source data should be the tin Turing cache, the cache of Turing, and the format is tin, TIN. And we also need the vector data. We need to set the data source and data site of the vector data, and symbolic distance and match type. Also, we need to set the result data, where we want to store the result of this process. So in order to input this source path, first, of course, we need to generate the tin data first based on our DEM data. What can we do? Actually, it's not hard. For the DEM data, like this one is a Turing, this is the data. We can right click and choose generate cache. Right click at the data site and choose generate cache. Okay, and this is a panel for generate the cache of data set. We need to set the cache name, the cache path. Let me give it a new path. Like this is day 1, and I want to create a folder, name it as day 6. Yeah, we need to store our tin cache data here. Click OK. And for others, like the storage type, the tile size, the begin level and end level, all of them will be filled automatically by the software. So we can just put them as default. Then click OK. It will take a few minutes, or it's already finished, to create the tin cache. Let's take a look at the result. Yeah, this one's a day 6, and inside of it, we can see this is the cache we generated. In the folder, it means the different number means the different level, and it stored the IDS file and the CF file. Actually, the CS file is the orange no tin file, and the IDs store the attributes or some ID of this one. And there is another one which is SCT, and that one is a Windows script component file. If we open it with the Notepad++, we can see we can see all of the information of it, such as like the cache name and the file extent name, the story type, the tile split type, and a lot of the different information for different levels, such as there are level from 3 to 8, and for the level 3, what is the information, and the start column, start row, end column, and end row. So it's stored all of this kind of basic information of our Turing data. And in a desktop, if we want to load the Turing, the tin Turing, we just need to choose this SCT file. Okay, now back to our desktop, and we go to the extracting 3D data again. So for the source path, we can already choose our data from day 6 and choose the SCT. Okay, and for the vector data, we need to use our building data set, right? We need to use our building data set, and the symbolic distance as default it is 1 meter, but of course we can set it as bigger because the accuracy of our Turing data is not very good. You can see the grid is very big, right? And then the match type we can choose. We match if it is a turbine, we match it on the based on the top or based on the bottom. Usually we just need to put it as default, the top. Then click OK. We will generate the cache. We will generate the cache. But in order to show you the progress, because we can see our building data, there are like 106,000, more than 106,000 features, 1,000 items inside of this data. So if I deal with this data, it will take a long time, around 1 hour, based on my normal PC. This is only a normal laptop. So I decide to, based on a few of the data, to just to show you the progress. So yeah, but on your side, it's also suggested to only choose a few parts of data to generate the cache, to deal with them, because that is based on the performance of your PC. If your PC has a very high configuration, then it won't take a long time. But if it's just a normal PC, and when the data volume is big, it will take a longer time, a few hours. So here I will use the clip to clip only a few of the data and just show the progress with you. Okay, such as this one. And I think all of us are already familiar with the map clip, right? After we choose it, we need to choose which layer we want to clip and give it a name and click OK. Okay, now we can see we already have this kind of data here, and I choose this one because they are near to the mountain, and we can see the differences. All right, and next we can use this extract 3D tool and choose the SCT file, and the data site is building test, sampling distance is 1 meter, match type is top, and the data site name of result data site, we give it like the test, and click OK. It will take a few time, and actually here I already added another one. I already based on the building, based on the whole building, to generate to create the height of it. Yeah, you can see that is this one. But let me check. Cadastral data, extract data test. Where is it? Let me open this workspace again. Something wrong with the earlier progress. Let me do it again. Based on the day 6, and this one should be the building. Choose this part. Sorry, let me do it again. And this one, give it a name, building. Okay. Yeah, now we have the building test, and then go to the 3D data, tool, extract data, and set the SAT. It's in the yeah, day 6. And here is the building test. The top extract data 1, click OK. Oh, yeah, now we have the result here. Sorry, something wrong with the earlier operation. Now we have the extract data here. And if we right click, and yeah, and we can see the data site type is already a 3D region. It's a 3D polygon data site. And if we add it to the new spherical scene and jump to the layer, we can see if we didn't add the terrain data, they are all like on the sky besides of the ground, right? And here in the terrain layer, we can add terrain cache layer and add our terrain here. So now we can see after we add the terrain, they are all climbed to the ground, right? Because yeah, they're based on the terrain, they are all climbed to the ground. I just choose a few of the data, for example. Okay, and what should we do next? First, we can select the vector data of this layer, and then go to style setting, and here we can set the height of them. For example, if I set all of them are 30 meters high, then we can say all of them already stand up based on the height, and all of them has the same height. Okay, but the problem is we don't have any of the height and in the attribute table, yeah, this height is added earlier. Sorry, and let me delete it first. Okay, and you can see this is the default attribute table of the data we downloaded from the OSM, and there is no height information of every building. So just for example, if we want to add the height for them, first we can right click at the data site and choose properties, and here we can go to the attribute table and click add to add a new field of this data site, and give it a name as height, and the type we can set as inch, and click apply. Then there will be some height, and based on the and for the height, we can go to like survey to set the different height, or we can just give them the same number. Or here I have one idea, which is we can based on the area to calculate the height of it. Such as if we can see the area, some of them are more than 1,000, right? Some of them are more than 1,000, but some of them are only like 100 square meters, and even this one is 22 square meters. So first, we can based on the SQL query to get to set to collect the select is extract data all, and where is the here we can choose the SM area less than how about it if it's 500 less than 1,000 square meters, then we can query them out. Less than sorry, this one query, yeah, and now we can get all of the we can get all of the building which is the area less than 1,000 square meters, and we can give them the height, like right click at the height and choose update field, and we can give them the same height, which is for example like 9 meters. Okay, and apply. And for others, we can say some of them already have the height. Actually, almost all of them. But this kind of building, they have big area. They have big area, like more than 1,000 square meters. So for others, we can based on the area to calculate the height just for the simulation, right? Okay, so we go to SQL query again, and like this one is if they are more than 1,000, we query them out. Yeah, there are only a few of them, and we also can update the field, and here the operation method, operation module we can use based on the single field, right? And then the operation field we can choose SM area, and divide two, then divide 200. Yeah, divide 200 and click apply. I think maybe 100 will be better. Yeah, 100 will be better. Okay, if we choose like them, then all of the height will be different for this kind of building. But this one is too high. It has more than 10,000 square meters. So we just give it as maybe 20 or 30. Yeah, and this one, we also give it the max height of 30. And this one, 30. Okay. Just like this. And then we can take a look at our attributes table again. Then all of them already have height, and they are all different. Okay, now we can go back to our scene, and we select this layer and go to layer style setting. Now in the height, we can choose the different height for different building. So it's just something like this. So now the different heights already have the different building. If the area is bigger, then the height is taller. Then this building is taller. Okay, just for example, we choose some of them. And of course, if you want to put the texture for it, like the side texture, we can select the picture from them. Let me find one picture, which is, you can find it from here. For example, if I choose the side texture, then we will put the window on it, and also the top texture we can put the top texture like this. Then in this way, all of them will be have the texture, the side texture and the top texture. But personally, I don't like to give them the texture because they are just we even don't have the detailed model of the building. We just extract them, we just extend them from a bottom surface. So if we set the texture for them, then it will also look weird. Okay, so it's the same if we based on our earlier data to do this operation. Let me show you. If I hide this one and add the complete data here, yeah, you can see this is the complete data for all of our building. Yeah, because the data is too big, that there is a pretty massive data, so the rendering is kind of late, is kind of slow, right? Like this. And if we set height for the extent, we can say different building has different height, and they are all like this. All right, we just put all of them on the terrain and take them like this. Okay, and let me remove it first, and put our data here. All right, and next, actually, we already finished to construct. We already finished to construct our 3D scene. It's not hard, but before we use iServer to publish the data, we still need to do one last operation, which is generate the cache of the building layer. Generate the cache of the building layer. So first, we can save our scene, like save it inside of the scene, and then right-click of the scene to create scene cache. Create scene cache. Okay, and here we can choose to create that there is only one layer we can create the cache, and the cache type we can choose to set 3D tile or vector. Yeah, here we just set the 3D tile, and we give it the name, like we set it to the day6, and then the storage type and the file type, we just put them as default, then click generate. And this part also will take a long time if our data is too big. Yeah, and let's take a look at our results, the day6, the extract data, and inside of it, we have this information. Those are tiles in different level, and then there is a JSON file which stores the attributes table of all of our the attributes table of the data site, right? And then the SCP, it shows the basic information of this cache. So in a desktop, we can go back and like delete this scene, and then we can create a new spherical scene. And in the general layer, we can choose add OSGB cache layer, and then find our data, like day6, extract data, and then choose the SCP file. And based on each jump to the layer, we can say all of our building are already generated. And of course, we need to add the terrain. We need to add the terrain from the SCT. Okay, now we can say they are already matched to each other, the building and the terrain, right? So and we can close this window and give it a name as cadastral scene test, and click OK. And now actually we already finished all of them. Let me show you the results I did based on the complete data. This is the result I generated. I take a few hours to finish all of them, and they will take a few time to load all of them. And we can say they are all overlay with the terrain correctly. Okay. And next step is, yeah, let's save it, and of course don't forget to save our workspace. All right. And next step is we need to publish our data to the Supermap iServer, which is here. And we can go to the manager and click and input all the administrator accounts of our iServer, and then go to service management, and here you can see I already published my earlier data, but how to publish it? We can go to quickly publish service, and of course it's choose the workspace, and we need to find the path of our workspace. The workspace file is in day one, okay? And click next. And here we can choose REST 3D service, REST 3D service, and click next. Then click finish. We will publish our workspace and our scene as the 3D service. Here, if you click finish, you will successfully publish it. But since I already published it, so I will just show you the result of publishment. And we go to the service address of 3D service, right? And we can see there are two levels. There are two child nodes, the domain component and the real space. In the real space, we can go to data. We can get the data, sign, and symbols like the scenes. Here we can see there are two scenes in our workspace. Yeah, we can see there are two scenes, right? And if we choose this scene and click view it in WebGL 3D, here we can see all the building already can be shown here. All right, and of course they are overlay with the terrain. So now there is only building and terrain, but later we will add the being. We will also add the being map as a base map in the 3D scene, but that will be the content of tomorrow. Okay, so let's go back to our training schedule. Today, our task is to create the 3D scene and process the 3D data using Supermap iDesktop. And then we need to publish the 3D service using iServer. So let's review our content today. For processing and creating the 3D scene, first, we need to construct our 3D scene. How to do it? We need to generate the terrain cache of DEM data to extract the 3D data, right? And after that, we can set the different height of the building based on the, we can set it based on the type or based on the area, or based on, like, we can just import the specific number. And then we can configure the extracted data in the 3D scene. We can say we set the height as the attribute we created. And then before the publishment, we need to generate the cache of 3D scene, right? And after that, we need to create a new scene, create a new spherical scene, and add all of our cache inside. After that, we can publish our workspace as the 3D service. And in iServer, we already can preview them. All right, I think that's all of today's training. I think that's all of our today's training. Please let me know if you have any question. Okay, so if there is no any further question, I think we can call it a training today. Thank you for your time, and it's the same. We will upload the record video and the step document to the Google Classroom, and tomorrow that will be the last day. I will teach you how to create the 3D scene using iClient for WebGL, and also how to show our 3D scene with the base map, and how to like click to get the attributes of them. For example, it's like this. We click to get the attributes of all of this building. All right. Thank you very much. Thank you for your time. See you tomorrow.